Hi students, welcome back. Today we're going to be looking at section 2. This is about graphing systems of linear inequalities. So a system of linear inequalities is going to look something like this. So you could have a group of inequalities . They could have two or less variables. So notice here in the first inequality, we have an x and a y. In the second inequality, we have an x and a y. In the third inequality, we have just an x. So you could have up to two variables. It doesn't really matter. But the thing we need to keep in mind is when we look at each of these variables, these are all degree 1 polynomials. So when we talk about this, that's the linear part, is that we have to have degree 1. And the inequality part is instead of having equal signs, we have inequality signs. So that's what we mean when we say a system of linear inequalities. So there's going to be typically an infinite number of points that describe or that satisfy this system of inequalities. To describe this solution set, rather than writing an equation or something, we're going to draw a picture. So this really comes down to a graphing exercise. So a couple of things. If we want to talk about graphing an inequality, the first thing we want to do is to rearrange the inequality so it's in slope-intercept form. So for example, if I have 3x minus 5y is less than or equal to 2, the first thing I want to do is get this to look like y equals mx plus b. So subtract 3x from both sides. And the next thing is we'll divide both sides by -5. Now this is an important point. You have to remember when dealing with inequalities, when we divide by a negative, the inequality symbol has to flip directions. So that goes if you multiply by a negative also. But notice when we added or subtracted on this previous step, the inequality symbol didn't change at all. So it's only when multiplying or dividing both sides of an equation does the inequality symbol flip directions. Okay. So then what we're going to do is we'll decide whether the line that we're going to draw, this y equals mx plus b line, should be drawn with a dotted line or solid line. So if we have an or equal to inequality, we have a solid line. If we have strict inequalities, we have a dotted line. And then we have to decide on our shading, whether we should be shading above the line or below the line. So if we have something like this, we're going to shade above. But if we have something like these, we're going to shade below. Okay. So have to, when we're deciding which way direction we're shading, have to be in slope-intercept form. Okay, if it's not in slope-intercept form, we cannot just look at the inequality symbol to decide whether you're shading above or below. So since we're going to put it into slope-intercept form anyways, that makes life much, much easier to just think about it that way. So let's look at an example. let's say we want to graph the inequality 4x plus 2y is greater than 5. So again, we're going to start by putting this in slope-intercept form. So I'm going to subtract 4x from both sides, and then divide both sides by 2. And notice here I did not flip the inequality symbol because when we divided both sides, we divided by a positive. So that's my first step. To graph this line then, what I'm going to do is graph y equals negative 2x plus 2.5. I just need 2 points, right? So any old 2 points will do. Let's say I'm going to pick 0. And that gives me 2.5 when I plug 0 in for x. Negative 2 times 0 is 0. And then 0 plus 2.5 is 2.5. And then maybe I'll pick 2. 2 times negative 2 is negative 4. And plus 2.5 is negative 2.5. Or negative 1.5, excuse me. Okay. If I go and I look at this, tells me I'm going to be using a dotted line because it's a strict inequality, and we're going to be shading above because it's a greater than symbol. So let's go ahead and draw our graph then. Okay. So 0 and 2.5, it's about right there. And then 2 and negative 1.5 is about there. We said we needed to draw a dashed line, and we need to shade above. And that's it. That's how we graph a single inequality. Okay, so that's not too bad. What's the difference when we graph a system of inequalities? So let's look at an example. Okay, so the first thing I'm going to do is I'm just going to graph each of these two inequalities separately. So they're both already in slope-intercept form. This one needs a dotted line because it's a strict inequality. And then we're going to shade above because it's greater than. Here we're going to use a solid line because it's the or equal to inequality. And we're going to be shading below because it's a less than. So for my first, maybe I'll pick 0. So negative 2 times 0 is 0. And then minus 5 is negative 5. And then maybe I'll pick negative 2. Negative 2 times negative 2 is 4. And 4 minus 5 is negative 1. And I'll use a different color for this one. So let's say I pick 0. 0 plus 3 is 3. And maybe I'll pick negative 3. Negative 3 plus 3 is 0. Again, it doesn't really matter what points you pick. Any old points will do. You just need 2 points to describe your line. Okay, so I have 0, negative 5, and then negative 2, negative 1. And we said that this line was going to be our dashed line. And we're going to be shading above. Okay. Then we'll do our green. So that's 0, 3. and then negative 3, 0. We said this was going to be our solid line. And this one we were going to shade below. Okay. Now, when I actually draw my graph, I wouldn't want to draw it this way because I want to just shade the part that's in common to both of these equations or inequalities. So you see how this area here is shaded with both the red and the green. So when I write my final answer, I really just want to shade the place where they overlap, both. Okay. And that's it. So that's my solution. That's all I need to do. So I'm just going to be looking at the intersection of these things. Let's look at one more example, and then we'll be done with this section. So first thing I would want to do is put these into slope-intercept form, and they're already all in slope-intercept form, so I don't have to worry about that. This first one, I noticed that I would use a dotted line because it's a strict inequality, and I'd be shading below because it's a less than. Here we're going to have a solid line because it's an or equal to inequality, and we'll be shading above because it's a greater than or equal to. Let's actually kind of color code these, huh? That would probably be a good idea. And then the last one is also solid because it's an or equal to, and this time we're going to be shading below. So I'm going to make a separate XY table for each of the three inequalities. So the first one, maybe I'll pick 0 and I'll get negative 5, and then maybe I'll pick 2 and get negative 1. The next one, maybe I'll pick 0 and get 8, and then pick 2 and get 2. And for the last one, maybe I'll pick 0 and get 2, and then maybe I'll pick 4 and get 0. So let's see, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So let's start graphing. So I have 0, negative 5, and then 2, negative 1. We said this was going to be a dashed line. And we should be shading below. Okay, do the green one next. So I have 0, 8, and then 2, 2. We said this would be a solid line. And here we should be shading above. And then the last one, 0, 2. And then 4, 0 is also a solid line. And here we should be shading below. Oops. So now what I'm going to do is I'm going to look for the area that overlaps. And there's not much overlap here. I'm going to graph the overlapping gray. So the place where they all overlapped was this little wedge right in there. So that's going to be what our solution looks like. And that should give you everything you need to be able to do this assignment. So good luck, and we'll see you next time.